it's already like 3 years when I'm working for FreeBSD, so yeah. So our today outline, I will present you a Capsicum itself. I will describe what it is and how it works a little bit. Then I will show you how we Capsicumize some of the base tools. Then I will present you a new debugging infrastructure, which was presented last year, which is connected to the Capsicum. Then I will tell you a little bit how the Casper works and what it is itself. And I will tell you a little bit about the future, so outgoing work in Capsicum world. So, Capsicum. So in the dark ages of computer science, our process had something called ambient authority, which means that they had access to every single thing in our computer. That means they can create a connection to whatever they want. They can open any files from our disk. Of course, there are some restrictions about the users and so on, but mainly process can do anything they want. So Capsicum use is implementation of so-called capabilities, which is the different, totally different thing from ambient authority. That means in capability mode, we say that process has access only to the thing that the process should have access to. So if process works on file system, then it don't need to connect to the network. So he has some access to file system, but he don't have any access to networking. So Capsicum was introduced in FreeBSD 9. It was implemented mostly in Cambridge and by Robert Watson and Jonathan Anderson, with some cooperation from Google, from Ben Lowry. So the kernel infrastructure of Capsicum is one simple sysctl, which is cap-enter, which enters to the capability mode. After calling the syscall, we don't have access to any global namespaces. So here are all the global namespaces that we have in FreeBSD. So, for example, if we enter the capability mode, we don't have access to file path namespace. That means we cannot anymore open any directories, files on our disk. Or we don't have access to a protocol address, which means that we cannot create any connection to the network. So another part of Capsicum is so-called capability rights. Capability rights are rights that I call it like local capabilities. It's stored in the descriptor. So we can open, for example, a descriptor to a file system, to directory, and that means that we have a capability to that directory. We can do anything we want in that directory. So going a little bit further, Capsicum implements so-called capability rights, which means we can even further limit that descriptor itself. We can say, okay, this descriptor is read-only or write-only. That means that if we have a descriptor read-only and somebody tries to write, then kernel will say, no, you don't have a capability to do that. So here are some of Capsicum rights. We have like cap read or cap append. It's sometimes the capability rights Capsicum rights are dependent on the type of the descriptor. So, for example, we have a cap accept, which will be used only on the socket. And cap receive, which also will be used only on socket. So we can get capabilities in two ways in Capsicum. One is by getting access to some directories or some descriptors before entering the Capsicum. So before, for example, in the main phase, we open some directories, we open some socket connections, and we enter the capability mode. In that way, we have only access to those capabilities which we asked before entering the capability mode. Another way is by delegation. So because we can send descriptors by using Unix domain socket, we can send descriptor from one process to another one. So if we have, if some process have access to some directory, for example, or some other resource, then we can ask that process to give us the permission to that resource. So we have, for example, a sandboxed process with Capsicum, which can speak with another process, which privileged one, which has access to some resource, and we can ask that privileged process to give us the access to resources that we want. So, for example, we can ask the privileged process for some more files or some more or some connection to the network. So, is Capsicum hard? Capsicumizing hard. It's not for a new code. When we design everything in a separate with some separation, the implementation of Capsicum in our program is really, really easy. At Wheel System, we use it for almost our process or for all our daemons, but we designed our ecosystem to support that. So what about existing one? Is it hard or not? So in 2015, we had a Capsicum implemented in few tools. There are few nice tools like TCP/DAM or DH client, but most of them are SSHD, but we still was lacking from a lot of base system tools. And unfortunately, it took us a long time to get when we are now. In 2016, we have a little bit more programs that we Capsicumize. So there are simple programs like Yes, which is also Capsicumized, but we have also a little bit more complicated and which are not even in base system like IRC client, IRC, or package, which also is Capsicumized whenever it's needed. Even if we receive some package from the internet and we want to check the checksum of this package we download from the internet, it's comparing the counting of the hashes is done in Capsicum in capability mode. So our story starts from 2 bugs in 2016 of BS patch. Those was very easy. Those was very simple bugs which allow us to exploit BS patch. One of them was integer overflow, and another one was there was integer overflows. So Alan Jude, seeing those 2 patches, decided that, hey, how hard would it be to sandbox BS patch? So it turns out it wasn't so hard. So first of all, we need to read some code. I hope you see a little bit very good this code because we will have a lot of code in this presentation. So for step 0 of every sandboxing is to read the code. We need to understand how the code works. It's not important if we are using seccomp, pledge, or Capsicum, or whatever. We need to understand what our code does. So BS patch is an application that for patching the source code or some files. So it's work mostly on 2 files. One which is patch and another file that we are patching. So here we have some random opens, which I mentioned earlier, that we need to open some files in BS patch. And those are interesting things in Capsicum because we cannot open files in capability mode. So step 1 is to reorganize the code. Like I mentioned before, one of the ways to obtain any privileges in the capability mode is to open everything that we need before entering the Capsicum itself. So we just reorganize the code and we put all the opens before entering the capability mode. So we just need to call cap-enter after all those opens, and we are already sandboxed the BS patch. We can go even further, and we can see that we can see how the application is working with those descriptions. Here, for example, it's just doing some reads. And here we have some F6. So after reading that, we can go a step further and limit the descriptors to do only that. So we have, for example, we have what I showed you before. We give the descriptors capability to read and seek. If somebody would still exploit the BS patch, then he can't do anything more with these descriptors than read and seek. So here is a patch for the sandboxing the CMP program, which is a very easy tool for comparing two files. And there in Capsicum we had some duplicated code, which we was doing all the time the same in every application. So we went, for example, here we limiting the std_out file descriptor. Most of the programs in base system are using std_out and std_in descriptor. So this was done in many applications. This is a little bit more complicated code because we not only limit the capability rights on the descriptor, but we also limit the IOCTLs that we can do on those descriptors. And another example, which is that in many applications we need to use, for example, error functions, which prints us some nice error message. And unfortunately for the NLS, native language support, we need to pre-open some files in the system. So unfortunately, this is not allowed in capability mode. We cannot open any files after entering the capability mode. We need to pre-open them before. So we introduced so-called Capsicum helpers. Those are a few inline functions that allow us to limit some of the most popular things. So we have like cap h limit stream, which limits all the free file descriptors for std_out, std_in, and std_err, or we can call the separate functions like std_out or std_in to limit only one of them. So instead of doing all that work that I showed you in the previous slide, we can call one function which will do that for us. So unfortunately, like I mentioned, libc isn't our friend, and like error needs from some NLS files for native language support, we have a little bit more issue with libc. For example, local time need to read time zone for our operating system. It's done only on the first call of local time, and it's cached the time zone for us. But when we call the first time the local time, it's pre-opened those files. So if we would do local time the first time after entering the capability mode, then unfortunately we would get wrong time. So we need to somehow pre-open those files. So we do that by introducing more Capsicum helpers like cat pages, which is done for caching the NLS files, or the TZ data, which allow us to pre-cache the local time data. So we can now deduplicate code, and now the code looks a little bit simple. We just limit the std_out and use another Capsicum helper to cache the NLS pages. Okay, so now I would like to tell you a little bit about the debugging infrastructure which we have in Capsicum. So from the beginning, keytrace implements supports from Capsicum. So we can key trace our program, and we are getting the information about the trace of the program. So key trace allows us to see which syscalls are called and what was the exit status. So the support for Capsicum in key trace is basically that it tells us which capabilities are missing. Unfortunately, this approach has two problems. One of them is that it's very easy to miss something. We just don't see, we can miss something in cat trace, and we need to also to use cat trace on every sandboxed program to know what was the trace of the program. So we need to see which syscall was done and if the syscall ended with error. So it's very hard, it's very easy to miss something. And it's hard also to cover all patches in the program, because there are some ifs which can be called or can be true in some condition and not true in another. So we need to test it in many ways. So here's an example of cat trace output. We call the cap enter, and we try to open some file that is not allowed in capability mode. So Konstantin present a new sysctl, which is called enodcap, which trap enodcap, which if something is done and it's not allowed in capability mode, the process will, the kernel will send the trap signal to the process. So we will create some core dump for analyzing our process. This is a little bit more handy in working system. We can have like a lot of capsicumized programs, and we can just see if something is starting broken in our system. We can also enable that by procCTL in our code if we want only one process to be traced, but this approach has also the same issue like before. It's hard to cover all paths of the program, and we are not sure if we are not failing in some conditions. So here is the core dump from one of the programs that was failing capability mode. Like we can see, we have a nice trace of the program where it was failing in capability mode. So we was calling the open, which is not allowed in our code in capability mode. So now I will introduce you to the Casper. Casper is a library that provides us the functionality that are not allowed in capability mode. So for example, if we want to create some sockets or open some files which is not allowed to in Capsicum, we can ask Casper to do that for us. So if we have some code that is duplicated in many programs, like we, for example, want to open some files and we don't want to fork and implement everything to all the IPC between the processes that are asking about give me another descriptor to the file, or give me another directory, or give me another connection to the internet, we can do that using Casper. So the APIs of Casper is very similar to libc. We try to not modify the APIs at all. So for example, if we have a getHostByName function and we have so equivalent in Casper is exactly the same interface between a libc version of getHostByName and the Casper one. So the idea behind Casper is to make a thing very easy to separate the programs. And we need to create Casper because Casper is a fork of our program before entering the capability mode. So how Casper works? So we have some process, And in that process, we call a function called capinit, which creates us the Casper. And now we can ask Casper to do some stuff for us. But before that, Casper is also forking the second time, so-called Zygote. Zygote is a very lightweight process that will be used to create new services for our programs. So now when we call cap service open, for example, to open the DNS service, we will clone the Zygote and create a service from it. And after that, Casper will pass us the connection to the service. And after that, if we only want to open one service, we can close the connection to the Casper, or we can ask Casper to create us more services. For example, a file system service or some other service. So after that, we can close connection to the Casper, and we can talk directly to the service, and we can ask him to provide us some information, like, for example, the DNS resolving DNS. So right now we have 5 Casper services. Like I mentioned, the system DNS services, which allow us to resolve some DNS names. We have gRP service, which allow us to work with the group operations, like searching information about the groups. We have PWD, which is used for password database operations. We have random service, which allow us to obtain some random data from service, and we have also sysctl service, which allow us to get information from the operating system. So what is also very interesting about Casper is that all those services can be even further limited. So we can say that, okay, we want to resolve only IPv4 DNS. If somebody will try to resolve IPv6, Casper would return an error that this is not allowed. Or we can even go a little bit further and say, okay, I want to limit Casper to be able only to resolve one domain, like, I don't know, Google.com. And if we would try to resolve other names, then Casper would say, okay, that's not allowed in our system. So this is the limitation in the Casper itself, but we can also go a little bit further and limit the Casper itself and say, okay, I'm interested in creating only system DNS and not others services. So here we have a traceroute. We have a patch for the traceroute, which use Casper for sandboxing. So, like I mentioned before, we create Casper by calling capinit. It's done on the top of the patch. Then we open service by calling cap service open. We open the DNS service, and we are limiting the service to name and address for resolving, and we are limiting Casper for IPv4 only. And after we do that, we can enter the capability mode, and this is we also limit here the so yeah, we also limit the other things in traceroute itself, like we limit the send socket to be able only to send the packages, and we limit the receive socket only to be able to receive. After that, we need also to replace our getHostByName syscalls function call to cap getHostByName. Unfortunately, right now we also add the if defs that if, for example, traceroute isn't in it's not in the it is in the base system, but it's not it's maintaining also by others. So we need to add like if defs that we have or not have Casper itself in the base system. So now I would like to tell you about a little bit about the future of Capsicum and what its ongoing work in that field. One of the things we are working right now is Casper mocks. Like I showed you before on the patch, we have a lot of if-defs in our code. The idea of Casper mocks is that we will hide all the if-defs inside the Casper itself. So Casper will you will only compile Casper once, and Casper will decide if we have if we are using a real function or not. So we have all Casper functions will be mocked for us. So we will not need to do that in the code itself. There is existing review of this change. Unfortunately, it is like a third implementation of those mocks. We had a few ideas how to do that. One of them was by just mock it in the library. So we would have a libcasper version of library which is not it's not doing anything, it's just calling the standard libc functions. This approach was dropped because we didn't want to link to the library that don't do anything. So the approach that we are trying to do now is to implement mocks using a lot of inlines and defines. And we would not need to link to the library itself. We would just need to include the header itself. We have a lot of ideas around the Casper. So one of them is to integrate the Casper in the libc itself, and we would just inside the libc, we would decide if we have Casper or not, or how we want to do like get host by name function. If we want to use in the secure way using other process, or we want to use the standard path. Other approach we are thinking is make a libc in FreeBSD more pluggable. That means that we could register different version of libc, different version of get host by name depending on libraries that we are linking to. So we would have like structure or of the functions, and we would just in our we could just change the implementation of the get host by name dynamically. So right now we also need to call cap init. With those changes, we also could do that in the start functions. That means that we would not need to call it in the main function itself. We would just have the Casper and we would just use it transparently in our program. So we are also thinking about the sandboxing services itself. Right now, Casper is not sandboxed at all. It is privilege process, and he has ambient authority to everything. So if somebody would exploit the IPC between Casper and the process, then he would get access to all of our data. So we also want to somehow sandbox the Casper itself, and we think this everything which are we doing here with the Casper is also about reducing the TCP, trusted code base. So we don't need to now trust the whole libc code, but we need to trust that our IPC library is safe between Casper and process. So it is also some surface for the attack, but it's still smaller than whole libc. So we're also thinking about introducing new Casper services, like file system, which is missing from for a while, and it's important for us because it's stopping us from sandboxing a lot of base tools, like tools that are that are working on multiple files, like for example grep. We also thinking about implementing, for example, services called System TLS, which would allow us to create a TLS socket, and Casper would provide us all the negotiation between our process and the internet. We also want to implement the socket services, which will allow us to create arbitrary socket to the internet, raw sockets, without any encryption and so on. We was discussing also to implement like configuration service, which will provide us the configuration of the file. So we would have like this is also very interesting from the operating system point of view, because we can have a lot of different formats of the configuration, and Casper would be responsible for parsing them and send us the configuration in a unified way. So there are two more very interesting services, syslog and login, and we will look a little bit closer why we would like to implement them in FreeBSD. So unfortunately, right now, if we would we are using the sysdel that send the trap inocap in our system. DH client on the start of the system will tell us that something is wrong. So let's see a little bit closer what is wrong with the DH client. As we can see, it's create a core dump for us. It's like I said, it's receiving the trap signal from the kernel. So if we will see closer in the trace, we see that ifc is trying to do connections, connect to the somewhere. So if we would see a little bit closer to the code, we can see that it's called from the so DH client is trying to do connection, and as we can see, I didn't mark that, but I hope it's visible for you. It's trying to call, it's the connection which is trying to do is done by syslog itself. So we can see now the code of the DH client, the sandboxing of the DH client, and it tries to pre-open the syslog before entering the capability mode. So everything should be fine. Unfortunately, syslog is very interesting, and I think it's kind of messy code, unfortunately. And OpenLog don't return us any value. It means it's always succeeding. So we cannot fail when we try to OpenLog. We also can fail when we are trying to log something. So it's always succeeding. Unfortunately, this isn't true because as you can see, DH client is started after syslogd. So it turns out that DH client cannot connect to the syslog at the time, and we cannot even print the error because we don't know about that. So we have two approaches to this problem. We can change the order of the syslog and the DH client, and or we can just implement the Casper services, which will provide us the all the functionality of syslogd. I didn't mention that why this connection was tried to do and why it's failed. It's because the syslog tried to reconnect every time when we try to log something to in the operating system. So if we're trying to send some log and it's not connected to syslogd, then he tries to reconnect. And because we don't have information that it's connected or not, it's failed in the capability mode because he's trying to do a connection to syslogd, and this is disallowed in capability mode. So another example is SSHD, which is also failing on my machine when I enter the inotcap mode. So when I try to SSH to it, I see in the dmask that something is wrong with my SSHD. So after doing all the work with seeing the debugger and seeing what is wrong with the trace, we see that there is a part of the code which is called GTP pvu class. This code is failing in our sandbox. This function is responsible for reading the login.conf and etc login.conf files. And unfortunately, we can't pre-open those files because before authorization, we don't know which file to open because it's a home directory of the user that is trying to log in. So we also would be, I'm also working on implementing the system login to provide the functionality for reading those files. And what is also very interesting about this part of the code, which is broken in the FreeBSD, is that this code exists only in the FreeBSD. This patch is maintained only by FreeBSD developers. So I would like to thank a few people that contribute a lot to the project from last year. Alan Judd, which done most of the Capsicumize, especially the BS patch. Baptiste, Conrad, and Ed, which also did a lot of work around Capsicum, and Konstantin, which implemented the sysctl enodecap. So thank you very much. Are there any questions?
So at this point, how many of the base programs, what percentage maybe of the base programs have been Capsicum?
So at the beginning of the presentation, I saw.
You gave the list through 16.
Yes. So this is the all that was sandboxed in the 2016, and the list before is with all the sandboxed applications. So those two lists contains all the sandboxed application right now in the FreeBSD operating system.
To finish Rick's question, I think almost everything the set UID is done, and all things there and well. For the system.login service, have you actually looked at the login.conf parser that's used?
Yes, it is terrible.
I've asked to make it better, but it's not much.
Yeah.
I'd be interested in coordinating that with afterwards so that we could just throw the whole under a bus.
Yeah, this was my first attempt to read the syslog code, and it was very, very messy. And I'm very surprised that we use that code still. But yeah, it's very messy.
Yeah, thanks for the talk. So you're saying that you are trying to implement more services
Yes.
for Casper, and you said that Casper actually introduced some smaller but still surface of attack.
Yes.
Does introducing new services actually increases the surface of attack, or it doesn't?
So the surface will be the same because it's still the same library that we are using for IPC. So the surface will be the same, but we need new services to make Capsicum a little bit more usable in many cases. For example, we cannot implement grep. We cannot Capsicumize grep right now because we are missing the whole file system namespace. So we could do workaround, like the fork from the grep, and try to, implement ad hoc the service itself, but it would make the code, I think this would introduce the bigger surface of attack, because it's a specific implementation only for one application.
No more questions?
Yeah, my question is just for my interest. I think that now Casper and Capsicum are a little bit different rather than OpenBSD Flash.
Yes.
So please give me your idea about the difference between Casper and Flash.
Okay, so the difference is in the approach of the rights that we are accessing. So Capsicum says that you have a right to some capabilities inside the program, and they are managed by file descriptors. So you have like the right to open the files in that directory, or you have a file, or you have a descriptors to connect to the internet and so on. In my opinion, in Pledge, the approach is a little bit different, and you say, okay, this is the namespace, use that namespace, and you get the access to whole namespace. So in some cases, Pledge is very useful. For example, if we would see the version of Pledge at WC, it's great. It's just like one Pledge call, entered, you have access to file system, I don't care anymore, right? And it's great. But if we would go a little bit further, and for example, if some developer would give too many rights to the program. For example, I'm giving you the access to my file system namespace, and I also giving you the access to network. Then the application itself isn't so secure, because I can read all your data and send it over the internet. So Pledge is more like about the reducing the surface of the attack in the application, but making some sorry, I missed the word. Making some so it's easier to use, but it's a little bit less secure in some cases. What I also don't like about Pledge, and I hope OpenBSD people will figure out how to fix that, is that if you would fork in the Pledge application and do exec on any program, then the new program is without sandbox. So you can in some cases. Theoretically, you can escape from the sandbox itself. In Capsicum, you don't have such issue. You always are fully secure, because you have only limited rights to do things in Capsicum. And this is also why the Capsicum is a little bit harder to implement in some applications.
Okay, I have a next question. On this approach, I think that is over 500 comments they apply the French system for, but we previously very few comments apply the Capsicum and Casper. Should we do more use of Casper for the more common or not?
So yes, we would like to do that. One of the things is the missing file system, for example, that is lacking from long time already. It should be done soon, I hope. And we, outside that, so this stops us for sandboxing all the programs that use the file system. So like grep, like WC, and so on. This makes it a nightmare to sandbox such applications. And besides that, yes, we would like to see more patches in Capsicum and more sandboxed application. And yeah.
To get back to the difference between pledge and Capsicum, for example, if you try to pledge BS hash, in the Capsicum version, you can only read from the cache file and not write to it, and only write from the file you're caching and not read from it. Whereas with pledge, you give the pledges a read and write, and means you can read and write to any file anywhere in the system. Right? And so
Yes.
If you apply pledge to BS hash, it would be both the same amount of work as doing Capsicum, but it wouldn't be nearly as good.
So again, it's a bigger surface of attack, right? Because in Pledge, like you mentioned, you have access to whole file system. It's read-write. You can do whatever you want with the file system itself. But in Capsicum, you have two descriptors. You have only those two writes to work with, and there are very specific ones, and you cannot do anything more.
I could also add something to the pledge versus Capsicum discussion. One of the things where pledge versus Capsicum is that Capsicum is sort of a form of object-oriented programming in a certain way. You have all scripts to which you write, which means that it also works really well in applications that are built in an object-oriented way. Whereas with pledge, it's just the case that the program starts up and inside of the main function, you already have to decide which rights you're going to grant to the entire application. Pledges approach may work well for, well, the BSD-based system where tools are relatively compact. But in my opinion, I won't see it scale in situations where you have to work with a lot of third-party libraries, where it's really hard to judge from the outside how you're going to restrict the application. So for example, if you're going to make use of some kind of pretty complex I don't know, what's the name again? OpenAL, OpenAI, some kind of OpenCV, that's the name.
OpenCV, yeah.
How are you going to judge from the outside which rights you need to put on the application to make that library work correctly? That's something that is pretty hard with Pledge, but it's pretty easy with Capsicum. If everything is based on policy, then it's all about it.
Yes, unfortunately, there is also, to be fair with the Pledge, right? It's also hard with a lot of third-party libraries because they, for example, don't work with descriptors and do like some open, hidden calls to the inside themselves. I remember we had like one issue with sandboxing. I don't remember which application, but it was the issue that we are the library itself, third-party library, was opening directly the def random, and nobody saw that in the code. So we was unable to open the random number generator, and we was using like we didn't have enough entropy to generate correct numbers. So to be fair, both approach has downsides and upsides, and there are different approach to the problem. In my opinion, one is like Ed said, it's like objective approach when you have access to the one object or few objects, to the set of objects, and another one is to have access to whole namespace. In some cases, the access to whole namespaces works great, but in more complicated applications, it will have exactly the same. If we would like to do it in correct way, the secure way, it will have the same issue. For example, I saw the implementation of the MUD, the mail client in Pledge, and they in Pledge you have access, of course, to the file system. You have access to the network, and you have also access to the fork and exec. And this is done because they can't reload the configuration itself. So they just fork and exec one more time the application itself to regenerate, to reload the configuration. This is a big attack surface for the attacker, because if I can open the client itself, why I will open the client itself? Maybe I will open netcat with some arguments and just create a backdoor to the system. So yeah, it's different approach, and in some approaches the pledge was great. In some, I would be more secure. I would feel more secure using Capsicum.
Thanks for a nice talk. You've piqued my interest, so I want to go and try and customize something. Can you tell me how I should choose a nice juicy target? What sort of things are in dire need of being customized?
I didn't put it on the presentation, but we have a very nice wiki page of the FreeBSD about the Capsicum. There is a full list of the applications that are already sandboxed, and there is a list of the applications that are waiting and there are that we want to sandbox in the future.
More what features about the program would make it potentially risky and therefore should be prioritized?
So the most risky I will not give you the list of the application itself because I don't remember, but the most risky applications are those that are working with some kind of parsers, right? For example, grep is a great example when we had a lot of issue with greps because it has a very complicated syntax of regexes, and it's very easy to find somehow that it's exploitable. So everything that is like parsers and so on should be sandboxed. For example, TCP dump, right? We are receiving the package from untrusted source. We are also doing some analysis of this package. It's also very unsecure. So we also are I would also recommend to find an application that is working with untrusted input, like, for example, the network one, right? I guess the applications like WC, for example, which only counts and don't work with real data itself, right? Can go on in the next step, basically.
Any more questions? So then, thank you.
Thank you very much.